Okay, how are we going to go about presenting the data? So a lot of these have already been covered in the previous slides. I've taken this out of the journal Cells, Instructions to Authors. If you're thinking of publishing in a paper, it's always worth looking at their instructions to authors, or if you're not planning to publish anytime soon, you can look at some of the papers that your lab has published in recently and look at their instructions to authors. So let's go through some of these. First of all, any alterations should be applied to the entire image. We've already covered that, right? We should clearly explain all alterations in the figure legend. We should only compare data that's appropriate to compare, e.g. data from the same experiment acquired the exact same way. And in Cell, they're saying individual images should not be used in multiple figures unless the figures describe different aspects of the same experiment. So you can't duplicate figures within a single publication. There's a couple of things that are also key to think about. So be aware of color sensitivity and color blindness, and also be aware of printing issues as well. And we'll cover those last 2 points over the next few slides. So first of all, color. Most fluorescence detectors are monochrome, which means your images are usually grayscale. So any color that we're seeing is being converted from the grayscale into color using something called a lookup table. Three of the most commonly used lookup tables are shown here: the blue, green, and red lookup table. And in this case, zero intensity is black, maximum intensity is blue, and then we've got a linear scale between black and blue. Same for green, black to green, and green to red. Okay, so color sensitivity. Our eyes have different numbers of rods and cones, and we see light very differently. So I've taken the exact same image here and I've pseudo-colored it using the blue lookup table, the green lookup table, and the red lookup table. Now most of you will probably see best in the green or red wavelengths, in which case you'll probably see the most information in these images in green or red, and not so well in the blue channel. So again, you can change how people interpret your data depending on the color of the lookup table that you're using to present that data. Again, this is just a zoom in showing the same thing. When we look at our microscopy images, so for example on a computer, or if you're looking at it on your phone, then we're normally using what's called a red, green, blue color palette. So the colors are coming through from a mixture of different pixels which are showing red, green, and blue. So for example, if you want to see red on a computer screen, then you have full intensity red, no green, no blue. That gives you red, right? All green, no red, and no blue gives you green. No red, no green, all blue gives you blue. If you have a mixture of red and green, then that's yellow. And if you have a mixture of red and blue, that's going to give you magenta. So as I say, if you're looking at anything digitally, we're using that RGB color palette. Now this is what we call an additive color palette. So we can add all these things together and get the different colors. If you add them all, you get white. When it comes to actually printing and presenting your data, for example on a poster, then we use a different color palette. It's called the CMYK color palette, and that's what we call a subtractive color palette. So it works very differently to how you've set that data up on your computer screen. Now, this is showing us all the different colors that are available, and this triangle here shows us the RGB color palette. So if you guys have ever spent time setting up a nice panel of fluorescence images and you've got some really nice green channel in your panel, and then when you come to print it out it looks a bit washed out, that's because the CMYK color palette can't spread out as far into the green as the RGB color palette. Okay, so again it's not going to be as clear as it will be on your screen. So this is a standard kind of fluorescence panel. We've got our nuclei